Hello, everyone. Welcome to Locals Supporting Locals, the heartbeat of the Okanagan, with host Kevin Proteau featuring a special guest each week to discuss current political challenges and, more importantly, solutions. What's happening tonight, Kevin?
Good evening. Thank you very much, Vicki, and Vicki is my wonderful co-host here. As per our other shows, we're focusing on GMOs, herbicides, pesticides as a lead up to the march against Monsanto, which is taking place worldwide on May 24th. So our guest this evening is Dr. Thierry Vrain will be speaking on that. But before we do an introduction with him, just a couple of notes. We just had our first evening last night at the Wild Scallion here in Penticton, BC, where we started up a dinner, movie, and a chat because we feel that, there's a lot of awareness out there and a lot of great documentaries, and people are watching these and they're walking away with, wow, that's, informative, that's alarming, and they're not discussing solutions. So we just started that yesterday at Wild Scallion, and it was a great turnout, and I'm looking forward to doing more. And it's a discussion at the end of the day. So our guest today is Dr. Thierry Vrain, and just to give you a little bio on him, he's a retired soil biologist and genetic engineer who, after a 30-year career with Agricultural Canada, no longer supports genetic engineering in agriculture. During those years, he was the head of the research group of 40 professionals in biotechnology, the vice president and president of the national and international associations of soil biologists, and an associate editor of several scientific journals in Europe and in the USA. He was alarmed by the scientific evidence out of Europe and the rest of the world showing the toxicity of genetically engineered food sprayed with the herbicide Roundup. That is an integral part of the technology. Dr. Vrain is increasing public awareness about the toxicity of this herbicide now found in the air, in the rain, in the water, all over our food system, and in our urine and our bodies, and even our breast milk for women. And I can say I had the pleasure of meeting Dr. Thierry Vrain and Dr. Shiv Chopra when they came through just this past winter here with their tour, speaking up on GMOs and Roundup. So good evening, and thank you, and welcome to the show, Dr. Thierry Vrain.
Thank you, Kevin.
How are you?
Oh, I'm good, thank you. The end of a very beautiful day here in British Columbia. Quite warm, it's very pleasant.
Yes, I could say the same thing for up here. So, Dr. Vrain, if you can tell us what you're about and what drives you.
Oh my goodness, what am I about?
That's a question.
You said it in a few words. I had a long research career with Agriculture Canada, the Federal Department of Agriculture in Canada. I was a research scientist. I finished the last many years as the head of a large group of researchers, scientists, all in molecular biology, biotechnology. I retired 12 years ago and started my retirement quite happily and having a quiet life, and became a gardener as a hobby. And that's when I became more and more interested into organic. Somehow, reading about gardening, I learned things that I had not learned in graduate school, like, about the organic lifestyle. When I was a research scientist for Agriculture Canada, organic was a cult, so I really didn't have much time for that. However, being retired, I read more widely and learned quite a few things, and that made total sense as far as my soil biology background. So basically, I became organic 5-7 years ago. And becoming organic as well, that means that I was exposed to a lot more literature, scientific literature that I hadn't paid attention to or that I would normally not read, mostly out of Europe and the rest of the world, that basically said that there was some concern about genetically modified crops. If you feed lab animals genetically engineered corn and soy, they become sick. And that was very intriguing. And there's definitely, these experiments have been repeated many, many times. And so that was intriguing because it's very difficult to pinpoint how could the genetically modified crops be toxic, so to speak. So that became interesting to me, and that's when I read more widely. And it's only in the last year or so that I became, that I decided to speak publicly, because I realized that actually it's not so much about the genetically modified foods, genetically engineered crops, genetically engineered food. Actually, it's about the pesticide that is sprayed on those crops. So we can talk about that at length if you want, but if you want to talk about genetically modified organisms, I can do that. Most people are very curious. They don't really understand what it is.
Well, I'd like for you to talk about GMOs, because particularly because you have the background. You've actually been the genetic engineer. And now, in saying what you just said there, studying as a genetic engineer, so you don't get to see, you're just being shown the good out of what it is that you're doing, but you don't get to see the organic farming side of things, like a... Sorry,
I'm not sure what you're asking me.
Well, yeah, I'm trying to phrase it because properly here for you, but it's just funny how you had to retire and go into farming to realize that maybe the science that you were learning wasn't quite all that you thought it was.
Yeah, no, that didn't really. When I retired, I was still with the fire in my belly, so to speak, that there's absolutely nothing wrong with genetic engineering. It's a beautiful, powerful technology which can be used to do all kinds of very useful things. So that was the spirit in which we all had when I was working in my group in biotech, and even when I retired, I was still in that spirit. It's only in the last few years that I'm exposed to all kinds of research studies from the rest of the world, not in North America, none in North America, basically, but everywhere else. There's a flaw, there's something that is intriguing, that is concerning, that is really toxic, and so that's why I became more and more and more interested. Genetic engineering, if you had heard me speak 12 years ago or before I retired, I would have said genetic engineering is easy, simple, it's very powerful, it's something that we must use in agriculture because we can create new crops that will be resistant to the pests and therefore use less pesticide. So that was definitely an objective of my team and many, many people, even the biotech industry made that promise that basically their engineered crops would reduce the use of pesticide. So that's how it was then, and it was my job to speak and convince people that there was no danger, no concern, no risks. I did meet a lot of people who were very afraid, and basically I would just tell them, look, there's nothing to be afraid of. It's just because you don't know how it's done, and there cannot be anything of concern there. Well, I have changed my tune. I have changed my song. It's definitely, there is concern about genetically modified crops, but the concern is an indirect one. It's not necessarily about the genetic modification, although there are some reserves there. Of course, there's a lot of unknown, but it really has to do with the herbicide that is an integral part of the technology. Yes.
Yeah, no, and it's great to see that, when for a lot of people, especially with the scientist world, a lot of them have a hard time coming out admitting, like maybe there's something flawed in here, and it's great to see that, you saw that there was a flaw and then you decided to speak publicly on it. And I tip my hat to you for doing that, because sadly, once people go down that road, they tend not to want to, admit, like maybe there is something wrong.
Yeah. Yeah, it's again, like I said, it's not all that clear and evident what it is in the process. A lot of people, assume that the genetically engineered crops have some toxicity. Where could it come from? Well, the engineering process itself means that you're basically shooting a piece of DNA from usually a bacteria and shooting it into the nucleus of a plant cell. And then you're regenerating a whole plant out of that. When the piece of DNA that you want, the gene that you want, is in the plant cell, then you regenerate a whole plant. Every cell of the plant has the gene that you want. So let's say, for example, you want a plant that will be resistant to the herbicide Roundup. Well, all you need to do is to find, because, okay, I have to back up here. The herbicide Roundup kills plants because it impairs an enzyme, a very important enzyme of the plant, an enzyme that allows the plant to make proteins. And if that enzyme is impaired or killed, as I sometimes say, then the plant cannot make its own proteins. It cannot make its own pieces. It cannot survive, and it dies very quickly. So we've known that for a very, very long time. And somebody, obviously, at Monsanto decided that wouldn't it be useful, and I can come back to this point and give you the whole story if you want later. But somebody at Monsanto basically decided that wouldn't it be very useful to engineer the resistance to that Roundup herbicide in the plant. That enzyme, that protein, all enzymes have protein. They're called metalloproteins. Metallo because they have an atom of metal in the center of the molecule of the protein. So that enzyme is impaired, and so you can replace it. It's almost like you're doing a transplant, really, an organ transplant, where you're doing a protein transplant. You stick a gene, a piece of code, a DNA code, from a bacteria that has evolved to be resistant to the herbicide. I'm aware that my story is getting a little bit complicated here. Bacteria and plants use the same process to make their proteins. And so bacteria also have to evolve to become resistant. It's very much the equivalent of antibiotic resistance. Everybody knows about antibiotic resistance, how it builds up in bacteria if they are exposed to the antibiotic. So you can expose bacteria to the herbicide and you will create resistance. When you have resistant bacteria, you look for the enzyme, you look for the gene that codes for the enzyme, and that bacterial gene is now resistant. You can transplant that bacterial gene into the plant, and now you have a plant that is resistant to the herbicide. So it's not that complicated, it's not difficult to understand. It's just transplanting a gene from a bacteria into the plant. That's really what it comes to.
Okay, so the biotech industry blares loudly that we absolutely need this technology to feed the world. Is the technology really performing as it's supposed to? We hear of super weeds and gene flow problems. So what are your thoughts there?
Yeah. We need this technology to feed the world. Well, that's a point of view. I mean, the truth is that actually there is no increase in yield. It's very, very clear. Even the growers, the farmers who use the technology enthusiastically, I must say, know very well that they don't get any more yield. So this is not a real promise. So whether we need the technology to feed the world, well, I would say a lot of people disagree, including the United Nations, all kinds of organizations, particularly in the third world. People just basically do grow food the way they've grown food for a long time, and this modern technology doesn't really belong in the picture. So no, I don't think but this is my opinion. I don't know that we need that technology to feed the world.
Yes, I know, and that's pretty much where I stand. Is in my eyes, we don't need this technology, and it's all about corporatizing and privatizing, the world's food supply. And I mean, they're patenting, life here. And you see the seed prices of Monsanto. We'll just use Monsanto, even though I think there's between 4 and 6 different companies out there with this technology. But I mean, if their goal was to feed the world, why would they stop the farmers from using their seeds? You have to buy every year, and why would they create the Terminator seed, so that it actually dies, and you are forced now to buy seeds the following year. So that doesn't sound to me like a technology that's being used for good. Would you agree?
Well, you said a lot of things there, and some of them.
Sorry.
Yeah, I mean, on the whole, yeah, I can repeat myself and say yes.
Okay. So just to move on a little bit here, because you've been speaking more and more about glyphosate. And so what is so special about this pesticide, and why are you so concerned?
Okay, well, this is a very long story, so
okay.
Let me start at the beginning. Let's start in the early 1960s. We go back a long time. The early 1960s, there's a small to medium-sized chemical company in the USA that is looking to create a new chemical to clean up industrial boilers and pipes. When you have a kettle at home, and after using it for a few months, you have mineral deposit, mostly calcium, in your kettle, on the side of your kettle. Well, that's exactly the same thing that happens to boilers and pipes. Industrially speaking, there's minerals in the water, including calcium, and they deposit on the sides of the pipes, and they will clog the pipes. So it is useful to have, basically, to put a chemical in the water that will immobilize, that will solubilize the metals and the calcium. Okay, so this company is looking to create molecules to do that, and they created one that was a very, very small molecule, and they knew what they were doing, obviously. They knew how to look and where to look, and they created a very small molecule called glycine methylphosphonate, because it's a salt of phosphonic acid, and all the salts of phosphonic acid are known to have the property that these people were looking for. They can immobilize and solubilize metals. And so they created a number of them, and the glycine methylphosphonate won the prize, and they patented that chemical. They patented that molecule in 1964. This is public knowledge, totally accessible to the public. You can read the patent. And this chemical is patented as being a very strong and very broad spectrum chelator. It's a descaling agent in industrial jargon, a descaling agent to clean up the pipes and the boilers. So in chemistry, the property is called chelation, chelating agent, a chelator. And what it does, the small molecule has the capacity to basically grab onto a metal ion, an atom of metal, and hold it. And so basically it destroys the deposits in the boilers and the pipes, or in your kettle if you wanted to put that chemical in your kettle. So that's chelation, that's a chelator. That's what it does. That molecule, glyphosate, the name is shortened for glycine methylphosphonate. Glyphosate is a descaling agent, a chelating agent. Well, in 1969, after being used in industry as a descaling agent, and a very good one, in 1969 it was discovered that it kills plants. It kills plants extremely well. It kills almost all plants. Well, wouldn't that be wonderful to make it into a herbicide? And that's when Monsanto bought the patent in 1969 and made history, because this chemical has become the most successful herbicide and probably pesticide ever. This is 1969. So it was patented in 1969 as a herbicide. and it kills all plants, almost all plants. Very broad spectrum herbicide. Very useful because it almost has no toxicity. It has no acute toxicity. You can drink it, and you will still be standing an hour later or even the next day. You might get sick sometime, but anyway, it has basically no acute toxicity. So when it was patented as a herbicide and registered commercially, it was registered with no acute toxicity. And then, of course, when you have a patent, it's only valid for 20 years. So by the late 1980s, Monsanto was in a hurry to perfect their genetically engineered crops so that they could still have the monopoly on the herbicide. Because now the herbicide is not patented anymore, because a patent is only worth 20 years. And remember, it was patented as a herbicide in 1969. But now what they have is engineered crops that will be able to survive the being sprayed with the herbicide. And so since 1996 now, Monsanto, because they're by far the very biggest one in the game, you mentioned a few other corporations, the chemical corporations that are in the game, but they're very small in this field, in the field of genetically engineered crops. So in 1996, basically the herbicide, glyphosate, Roundup, it's the generic name is called Roundup. The herbicide is now sprayed on all engineered crops, basically. That's what it's for. We have today, this was 1996 when it started, we have today in 2014 about 500 million acres of genetically engineered crops in the world. And about 90% of that is sprayed with the herbicide Roundup. And of course, about half of that, not quite half of that, is in North America. And the other half is in South America and very few other places. India and China grow engineered cotton, but not really the food. So all that acreage being sprayed with a chemical, and did I say it was about 2 billion pounds per year today. You can do the math. 2 billion pounds of glyphosate being sprayed in genetically engineered crops every year. Well, I'm rounding up the numbers, but that's basically the order of it. So it's a huge amount, and all that glyphosate is in the air. Like I said, it's been measured, it's been shown. It's in the air, in the rain, in the water, in the drinking water for sure, in the food system, all over the food supply, all over the stores. It's in our urine, it's in the water, it's in our blood, and the breast milk of feeding women breastfeeding, and that was shown recently. So yes, I am very concerned.
Dr. Vrain, I'd like to ask a question. Now, a while ago, or a few minutes ago, you mentioned about something, and I thought it was glyphosate. That was tested so safe that you could drink it.
Yes.
But why is it now so toxic?
Thank you. Perfect question. Surely I was going to come to that, but this is good. So when the chemical was invented, I said basically no acute toxicity, with emphasis on the word acute. When it was discovered that it kills plants very, very broadly, it was also known already that it kills bacteria. Because bacteria and plants have the same enzyme. Mm-hmm. They share the same biochemical pathway to make proteins, and that enzyme in plants and in bacteria is impaired and killed because it does chelate onto the manganese atom that this enzyme, this protein, needs. And so the toxicity, the first, there is more than just one reason, but the first reason of the toxicity is that it kills bacteria. Now, 35 years ago, okay, so it kills bacteria, perhaps it's no big deal. Yeah, we vaguely know that we have bacteria in our belly, but we haven't really paid very much attention. That was 35 years ago. I would say in the last 10 years, the medical research establishment has made it very, very clear, very obvious that this huge community of 100 trillion bacteria in the human gut is the equivalent of an organ. They call it the microbiome, and it is just as important as your brain or your heart.
That's. I think this information is coming more and more out to the public now that we are actually about 10 times more made up of bacterial cells than our own cells.
Yes, I often say that to my to the listeners or the audience, that basically we're 10% human. and everybody looks at me with big eyes, and then I add, oh yes, but if you look for the genes and the proteins that bacteria can make, we are 1% human. 1% of our DNA in our whole body is human DNA. 99% of the genes in our body are bacterial genes.
Well, this should be a game changer then, shouldn't it?
No, it's a huge, it's a game changer. That's the word, yes.
But will industry understand that's a game changer? Will government understand that's a game changer? Or is this real-time science going to be employed, 20 or 30 years down the road, perhaps? I'm just asking for your opinion. Of course, you can't answer definitively.
No, before I answer you, I will say that I will say one last thing: is that glyphosate is patented as an antibiotic.
Right.
Monsanto patented glyphosate as an antibiotic in 2010. And this is, of course, public.
Yes.
Yeah. So it's like okay, yeah, and we know that it kills the good bugs, and it really is not that good killing the bad bugs like Salmonella and Clostridium, etc. So it's not terribly useful as an antibiotic, but you can follow my eyes when I look at the food supply. The way we grow our crops. If over 90% of corn and over 90% of soy and cotton and canola oil and cottonseed oil and what else did I miss? Quite a few of them, 100% of sugar beet, are engineered and doused with that chemical, then obviously it's in the food supply.
Yes.
And the residues are not measured. Nobody knows.
So I'm going to take a step back now and ask this. I know that you had talked about when you started to realize that there was a problem was basically after you retired and started gardening and started looking into other things. But during the near the end of your career, and I'm not sure when you retired.
I retired in 2002.
Okay. Near the end of your career, did you start to see the inkling that maybe the promises of that Monsanto and biotech was offering were not being fulfilled? For example, the higher crop yield and you're going to use less pesticides and all of that. Did you start to see any of that data coming through at that time, or just the start of it, perhaps?
No, not even a start of it.
Not even the start of it.
No, I was in the field.
Wow.
I was probably aware that there was I would put it this way, like I was telling you that organic was a cult. I would say opposition was a cult too. Like they were afraid, they were in fear for no good reason. That's just ignorance. It's just the Luddites. It's just backward people.
Yes.
That's where I was. Yeah.
Well, was that a built-in bias though in the education system?
Well, of course. Yeah. Yes.
So is education really because we see this in other fields? Is education possibly a contributing problem? Like, is there potentially? I don't know, but is there potentially maybe a little bit of dogma involved in science?
We are in a culture of technological progress. And that's what we are, and that's what we do, and that's what we teach, and that's what we teach our children.
Okay. But then I'm not meaning to put you on the spot at all, but because these are just you can't possibly answer them except for it's philosophical more than anything. Do you believe that when it comes to biotech and the whole pesticides, the herbicides, all of that, do you believe that the precautionary principle was fully engaged here? Was there enough independent studies? Or do you think that industry pressure maybe had something to do with this technology being pushed so hard around the world, not only by industry but by governments as well? And in particular, the U.S. government has been really pushing this technology despite all of the facts and figures coming out.
Yes, correct. And I would add that there is so much research, there is so much science out in the last 10 years or more, showing the extreme concerns, showing toxicity, for God's sake. Many governments have reacted or are reacting. Russia decided they want nothing to do with the technology. They don't want to import it. They don't want to import it in any way. For food, for cattle, for anything. They don't want to plant it. They want nothing to do with it. And they banned the herbicide.
Well, I was wondering about that story. I was wondering if that was because, we see so much propaganda coming from both sides now, that, political propaganda from both sides.
Yes.
And I was wondering, is that really the case in Russia, or is that just being, more propaganda coming out? I know that they're resistant to it a little bit, but is it really going to the...
Well, they're beyond resistant because basically for a year they've had some high-level consultation all over the land with their scientists who can read the literature, for God's sake. And I was not surprised at all, that's about 3 weeks ago, I think, or 4, that Prime Minister Medvedev announced that, they were going to have a law about that, etc. But they don't. I mean, I think it was he who said, the Americans want to eat that stuff and let them be, but we don't. So I'm paraphrasing.
Yeah.
And many other countries. I mean, Europe is famously resistant.
Yes.
I mean, like as soon as somebody says I'm going to grow engineered corn in France, well, I mean, they've got like people coming down with their flamethrowers, and they do the same in Hungary, et cetera, et cetera. So I,
Yeah, well, we're in a good way and in a bad way. We're rather passive in Canada, and
we are in the biotech bubble.
Yeah.
We are bombarded with, as you call it, propaganda, telling us that it's really safe and it's perfectly okay.
Yeah.
And most of the rest of the world agrees, or all of the rest of the world agrees, and it's like, whoa, no, this is not the right picture. Unfortunately, their market is shrinking. I don't think it was propaganda that it must be in the USDA data that many shipments of corn this year to China, we're talking huge quantities, that were turned down because they were contaminated with GMO.
Well, politically speaking, again, it's your opinion only. I'm thinking anyway. I'm thinking for myself that by Russia doing this, that it's going to give other countries more inner strength to be able to go against the U.S. in their constant push of this technology. I don't know. What do you think?
Yeah. I would agree with that. Yeah. It's it enables other countries, and I haven't told you half of the story about the toxicity of this thing. Yes, it does kill bacteria, but it also impairs many other enzymes. It basically, in a few words, I tell people this molecule is able to hold on, immobilize metal micronutrients in the food, making them unavailable. So basically, your food is depleted in metal micronutrients.
So a person is really starving to death while they're eating.
So, it's fine. We're talking toxicity here. So I said no acute toxicity, which is real, it's true. But then there's this depleting minerals aspect of it, which makes it a very chronic effect. It's a very insidious. It takes years. But people are basically depleting themselves, and then suddenly they're not functioning well. And then maybe, the bacteria in their biome was killed a long time ago, so that makes for a lot of gastrointestinal stuff. This is very serious.
Oh yes, and of course over the last 20 years we see in the real time medical science world where the number of the cases of gastrointestinal diseases like irritable bowel syndrome and colitis and there's like a half a dozen of them at least to name off, has just been skyrocketing. And maybe it could be very well due to the high grain eating, and the grains of course are a lot of them are genetically modified.
Yeah, I would say not a lot. I would say most.
Yeah.
If you want soybean in North America, you have to specify organic, and it's over 90% of soy is et cetera, et cetera.
Well, just a good question here. There were strict limits on the use of Monsanto's Roundup pesticide, and it was 200 parts per million. And an article that was put out by Heidi Osterman here with the True Food Foundation, apparently that has now changed to where they ramped it up to 6,000 parts per million, and that's our so-called Environmental Protection Agency, which has done that. Are you familiar with this?
I am somewhat familiar with the increase in legal allowable residues of Roundup and glyphosate in the food and the water from the EPA, the Environment Protection Agency. Yes. I remember the numbers, and I don't remember the numbers, but I remember the numbers in hundreds of parts per million, definitely not 6,000. That I would definitely remember that if I had seen that. So
apparently it's been ramped up to 6,000 parts per million now.
I would doubt that. I think there's a zero too many.
Well, yeah, one of the things is of course the Environmental Protection Agency is the United States, and we have a big United States audience here. But I'm not sure if the same EPA standards have been adopted in Canada, even if it was like less of zero. What is your experience working for the government of Canada? What is your experience in what Canada does the same or differently than the United States when it comes to these kinds of decisions?
I haven't looked for that information. It's not published on the net, and so it's not as easily accessible as the U.S. data.
Right.
Yeah. So you know what? I can't. I don't know. I guess I make a big assumption that obviously we must have the same. If we had to align our legal residues, it would be more aligned with the USA than with Europe. In Europe, they're notably lower. Like you can't have much less than you can in the USA. But I would estimate, I would assume that we have probably the same legal allowable residue limits.
Yeah.
In our food supply. So, yeah.
I'm more in the medical establishment industry than in this industry. But from looking at that industry, it seems that if the United States adopts something, Canada is very, very close to follow. Mm-hmm. Just because of the lobbying, basically, I would put it down to, or perhaps trade deals. Etc.
Yes. Well, I mean, I could. Yes, I agree with you. Sorry, I was going to give you some personal opinion that really don't belong to the topic here.
Oh no! Please give us your personal opinion.
Personal opinion is that we are a third world country next to a big giant, and we do what we're told. I don't think Mr. Harper. I don't, give Mr. Harper the credit for doing much independently. We just do what we're told. That's all.
Yeah.
So it goes for the food supply. It goes for the pesticides. It goes for the engineered crops. It goes for regulatory activities, et cetera, et cetera.
Well, I just want to bring up.
Appreciate that.
There's an article that came out of our Penticton Herald up here. There was a letter to the editor that was initially written by Heidi again Osterman in regards to her concerns over the depletion of the monarch, the extinction of monarch butterflies and glyphosates and Roundup. And just today it came out, and this is where they got us fighting each other here. Or here's a good example of it. A gentleman named Steve Boobdeby, hard to pronounce here. He rejects what Heidi has to say in regards to the safety of glyphosate and Roundup. And his comment, in short here, he says, with regard to Roundup on Monsanto, we need to understand why this company is in place. It is in place because farmers buy their products, and we in turn buy the farmers' products. Glyphosate, Roundup, is a safe chemical, and with the onset of climate change, it is a product that we need. Using Roundup to kill weeds rather than mowers, weed eaters, and has reduced the amount of carbon put into the air. It goes on from there, but wow. I mean, yeah. But at the same token, from what I understand with this gentleman, he is also the owner of a company here in town that uses chemicals. So, but that's where we're going back and forth, And so when you come out and talk like you are, and having the background and the knowledge that you have, you think more people would listen up. But because of money, investments, and we see that time and time again here, people are choosing to ignore, the science and the truth that's being spoken.
I think, Dr. Vrain, basically where that kind of opinion is coming from, that in my opinion, that Kevin is just talking about, is just what we alluded to earlier, is that the early science showed that glyphosate was completely safe and you could drink it. Mm-hmm. And people are not paying attention to the later research mm-hmm. that shows about, the effect on bacteria. Would you agree with that?
It's the direct effect on bacteria. It's also the effect on your own physiology. So the first line is definitely your microbiome, yes. But in turn, in time, you get depleted into all kinds of, think of it as like vitamins. It's just like it must absolutely be in your food. You need cobalt to make cobalamin, which is a protein called vitamin B12, et cetera, et cetera. You need all these atoms of metal, and this molecule just depletes the food.
I think
so it's not just about killing bacteria.
I think this has been a really so informative to have you on here. Every guest that we've had on every week gives a little bit more of a piece of the puzzle, and I think you have wrapped it up really nicely. Oh, sorry.
No, I thought Dr. Thierry was still speaking there. Yeah, thank you so much, Thierry, for coming on the show, because like Vicki just said, we've been getting so many different perspectives from different angles on GMOs and what to be aware of. Could you offer, because we're going to have to wrap it up in a few minutes here, some solutions?
Solution.
Personal solutions and political solutions.
I don't have any solutions. I mean, obviously, this is industrial agriculture. This is how we grow our food. And so, you can't take it away from the farmers, or you can't, I don't know. This is like really important. This is our system. And at the same time, obviously, the medical system is becoming very alarmed, and obviously, as you said, people are starting to fall ill. The statistics are there. You can look at the Center for Disease Control in Atlanta, Georgia. The statistics are there, and you can put them together with the statistics of the USDA, the U.S. Department of Agriculture, to see how much of the chemical was sprayed all over North America, and you can, it's really easy. You can see what the curves are saying. It's published.
So here's the question then, Dr. Vrain, is what have you done personally to solve the situation?
Oh.
For yourself?
Oh, I see. Well, I like to think that we must go beyond the personal. Yes, of course, personally, well, I grow as much of my own food, of course, as I can, and I sell some of it. We are a strange operation here. The CSA for me is a teaching tool. I sell food once a week. People come with their box, and we fill their box, and it's the tool for the students who are here, who live with us.
That's
Where
wonderful.
am I going? Give me your question again.
That's wonderful. Well, you've come up with your own solution. Is that I'm quite sure that you avoid these foods.
I grow my own food, and I am very aware of my food choices. And fortunately, I guess I'm in a minority, which should really become a majority of people who really are willing to invest in their health by buying much more expensive food, knowing that it is full of nutrients rather than the rest.
Absolutely.
It comes to that. One more thing that I haven't said, and that I definitely want to point a finger at because it's important for your listeners. This chemical is now, because it is deemed to be so safe and non-toxic, this chemical is also now spread on grain crops, potato crops, sugar cane, beans, pulse crops, and I'm sure a few others, and probably most of the grains, as a desiccant. It is sprayed as a desiccant to kill the plants just before harvest so that it is dry and it is a lot easier to harvest, the grain or the whatever. So it is used as a desiccant. Those crops, none of those crops are engineered.
Mm-hmm.
So knowing you've done your homework, you know that the grains are, of course, they've been engineered, but they're on the shelf. They're not commercialized. So none of those are engineered, and yet they're being spread.
So you're saying the chemical by itself is way more deadly to us or harmful to us than the actual genetically modified crop that employs it, because the chemical is spread far wider than just the GMO crops.
Yes, I guess you could say it that way. I guess what I'm saying is GMO crops are perhaps problematic in terms of direct toxicity,
mm-hmm.
but they are almost all sprayed with a herbicide. They contain residues of a toxic chemical. And then there are those extra crops that are not engineered and that are also sprayed. So yes, it is definitely becoming very widespread. And like I said, 500 million acres, 2 billion pounds, that's a lot of chemical every year.
Wow.
Thank you so much for...
It's been measured, Anyway, sorry, I can't stop.
Oh, we could go on for a long time.
We could, yes.
Thank you so much for, your added information that you've given us this week, and our listeners. This is great.
You're very welcome. You're very welcome.
Yes.
Quite pleased to be able to help.